So hopefully you've all watched the introductory video that talks about the variation service and the SNP callers and the aligners. Let's submit a job. As an example, we're going to use some data from that large megaplate example that we talked about in the introduction. All those samples are very closely related. It's a E. coli evolving in real time to antibiotic pressure. So that's going to impact some of the choices. So we go up here to Tools and Services, and we click on Variation Analysis. Now, remember, you can do paired reads, you can do single reads, or you can do the SRA accession, and you also have to have a target genome. Now, this can be a public genome that's available in BV-BRC, or it can be your own private genome. If you wanted to drill down into that, you could click on that filter, and I could say, I just want it to be my genomes. If you wanted to do that, I'm going to click that off. You can also enter the unique identifier because so many genomes are named the same thing. For example, if I put in Mycobacterium tuberculosis H37RV, and let's just see. Yeah, once you get that, it's like, oh, which one of these do I use? So if you have a unique identifier, that's easier. So I'm going to remove that, and I'm going to go to my text edit document, and this is my unique identifier for the genome I want to use. And this is one of the genomes from that particular experiment, the ones that I went ahead and assembled and annotated the isolates that were not exposed to antibiotics because I wanted it to be as close to them as possible and watching them evolve in real time. So we have that. That's what I called it, not very original. Well, actually, it's very original. I always am talking about naming things so you know what they were. So I look at this and I know I trimmed the reads. It was sample 106 and I used unicycler. So I always name things. Now, I could use paired reads and I could use single reads, but for this, we're going to do 3 separate run accession numbers. So I'm going to go back to that text edit and I'm going to use this run number, and I enter that into the box. I copy it and enter it, and then I have to click on this arrow to move it into the selected libraries box. And so you notice there was a quick brief message where it said that it was validating. The script goes to the SRA, makes sure it's a valid run number, and then brings it in. So that's our first one. Here's our second one. Okay. And then we want our third one. So those are all moved over. These are going to align these reads and look for SNPs against this particular genome. Now, because these samples were evolving in real time, when I use the aligner, and you know, we have BWA, memstrict, BowTie2, LAST, and Minimap2. Well, LAST wouldn't be appropriated because these happen to be short reads, and LAST is a liner for long reads. BWA mstrict is designed specifically for this situation. When you have things that are extremely close, like when you're looking at things that are happening during an epidemic and it's a time thing and you can see that they're evolving, you know there's a good close relationship. So I'm going to choose BWA mstrict, and for the SNP caller, I can do Freebase or BCF tools. I kind of like Freebase. I'm just doing it for this example. Let me point out that I will show you an example where I've done all the comparisons so you can look at those. And then I need an output folder. Why don't I create a new one for once? So I'm going to go in here, and you can see I have a bunch of folders here. And I think it's called the Kishoni megaplate in here. And I want to create a new folder that I'm going to call variation. So I know I'm looking at that, although most of those things would be in the variation anyhow, because these are all reads against a genome. So I've got the folder, and now I need a name and the diagrams in the paper, and also at biosample, call these manifolds. So it's manifold 96, 145, and 147, and then against E. coli. All right, so we're ready to submit it. The button is blue, we can submit. So let's do that. Now don't leave. It says it's submitting the job. Don't do anything until you can see that the job is successfully here. So it's been submitted successfully, and it's going to take a while. But in the next video, we'll look at the results. So I'll see you there.